Okay. Okay, so good afternoon to everyone. Today I will present the work called BIM for Digital Twin, the case study of Trento. I work for FBK, which is a company plan in Trento. Okay, maybe it's better in this way. Today I would like to present actually a work that is a part of an European project called INCUBE. I will have a very brief project description, the activity of the description of the activity, the process, and some next step and results that we have. INCUBE, first of all, is an European project which includes all these partners. It stands for an inclusive toolbox for accelerating and smartness deep renovation. The field of action of this project is the efficiency, the sustainability, and the inclusive energy use. Those are the keywords of the project. So there is digital twin, digital logbook, which are part of what I will explain today. But there is other concepts like renewable energy community, user comfort, and so on. The project duration was 3 years. Now was actually extended to another year, so it will end in June 2027 to allow 1 full year of monitoring of the activity. Here, as you know, all the project has a different work packaging. In project INCUBE, there are 3 demos, which are one in Trento, the one that I will focus on, one in Zaragoza, Spain, and one in Groningen. The Italian one, there is a plan to go from a state of art to a new kind of neighborhood, but I will explain you better. And here I also visualize some technology that will be applied to the demo. So there is, for example, machine drilling, robot demolition, pre-facade, drone, and so on. I will be focused on one work package, which is the 3 in this project. That it's the one that focusing on the digital twin. The digital twin that we that we working on was based on this building, which is called Santa Chiara building, which is part of a district, actually, a district called Santa Chiara, that includes 6 buildings. We recreated the most ancient and historical building of among those 6, which is the red one, if you can see the picture. And here I summarize some energy parameter of this building. First of all, the context is that we want to renovate through an energy efficiency system. This building is a historical, so required different consideration. We want to have the digital twins of this building, since we also have different sensors that need to be installed on this sensor. But first of all, to be able to assess that we actually have a digital twins of this building, there are the simulation that actually prove us that we were able to have a real digital twin. So we are able to study how this kind of building act. Here I just summarize which is normally the current workflow for digital twin. So you start maybe from the 3D surveying with photogrammetry, LiDAR, drones, and so on. Then you go to the 3D geometrical model, the building information model. This is the scan to BIM. And then usually you also go through the building energy model, so BIM to BEM. To go to what is the final step, the enrichment with dynamic data and analysis, the energy digital twin. Usually, I also summarize some aspect of this workflow in this slide, because the fact is this workflow, which is the current one, has some many steps. First of all, there is different steps that require different software, but usually you have some compatibility issues, and actually also frequent loss of data, because it's not so accurate as have just a single flow, for example. Just to repeat it, you go from an abstract point cloud to scan to bleed with software, but also other kind of software, and you go from IFC to the energy analysis, which is the last part of a BIM model, actually a digital twin model. Here, I would like to show you what are our steps, our analysis made inside in this project, which could be innovative, which could be a different workflow. We starting from the 3D modeling of general building envelope with the aerial data. Then we had the 3D surveying TLS with a Leica RTC 316. We take the point of facade and indoor parameter. Actually to be clear, we at beginning said that we will let a drones carving survey, but actually in this zone it was not possible to let drone fly, so we use the Leica model. Then, here I explain why actually we use we don't use anymore the drones, because for a safety reason. So my colleagues go scanning a lot of cloud points. Here, from the points that we have, the cloud of points, we have a process of cleaning and reassemble of the point clouds. So we go from that picture to the other ones. And then there is the data fusion, multi-resolution, and complete 3D final point clouds, where we were able to have the final geometrical BIM model, which is not so simple in a historical building, since also the surface are not really not precise, because obviously when an historical building was not, they were not so precise in their constructions. Then from here, I want to explain what was our analysis. So we take the BIM model and the TLS data set. We use our GitHub code to actually have to take the zone, to not only have the surface actually that of the building, but we also introduce what are the sensors that were installed in the different part of the building. Here there was a picture of the sensor that we installed to have monitoring of the energy consumption and also temperature. That is the part that I will show later. For this data, we have the data visualization, of course, of the temperature that will go in the BIM model, but actually we also have the visualization and predictive models that it will be part of our digital twin. So let me say, from the data that we can visualize that are real time, there is also a part of data that were elaborated to have forecasting model for the future, actually visualization to predict some how the building can act in some situation, guide about the consumption and also the production, because there is also a photovoltaic panel on these buildings. Here, for example, I showed the temperature that we monitoring for this zone. So those will be the data that we implemented in our model. Here I show the first part, which is the geometric reconstruction process, where we have the geometrical digital twin, but also the topologic model that we were able to have in one code. There is also a part that actually will not be part of this presentation, where we also we go deep into energy analysis. So stand with the first part. So from the classified point, we were able to extract the surfaces. From the surfaces, we were also able to extract the area, which is the topological model. And then we were able to have one model really for the simulations that actually includes a lot of information. Because where are the information that we also used in the BIM? So there is the volumetric information, which are the important ones for starting, and then we have also the energy model. So we were able to have the area, the U value of all the surfaces, and also other environmental parameter. Then, from this, the INCUBE conceptual architecture would like to have from the scan to bin to go to the digital twin. We have the INCUBE sophisticated digital twin engine, which is called DT. This part is the modular BIM sim platform created by CERTH, but there is the Eclipse Sensinak platform created by CANTU. In here, I will show you the CANTU platform, which is the one that will be the actually dashboard for the digital twin. Here, obviously, everything starts from the data collection that was handed by a code and a repository. The challenge was to have all the EFC format from the BIM and to go to the JSON format and have everything work on the last format. So this is one part of the store activity of the data. That was the one that then go to the BIM digital twin model. Here, for example, I will show you which is our INCUBE digital building logbook, where we can upload, where we actually have the login, and where we can see, based on the site, that can be Saragossa, Groningen, or Trento, all the data recorded in the building. This platform, where you can see there is the dashboard section, where there is location information of the building. This is just an example. Then there is the monitoring data session, which is the part of where we were able to actually see the information recorded in our main buildings. And then there is also the part of documentation, which can be, for example, the part of maintenance, the certification, the financial part, the legal part, so all in just one part. And then there is the management section, where actually you can, let me say, upload documentation, but where you can also have reminder to, for example, maintain some object or something else that regard the, let me say, to let the building work better. Then the last part to conclude this digital twin that we are creating, where here we can see other data visualization. It's the part where there is the integration of the activity of this project, where there is the smart building automation model for the real data set, the integration of the historical data, because it's also, we will also collect the data from historical, and we're also record the KPI for the project. And this part, let me say, it's still in the process. We have the first draft, but we are going to complete it. And then there is the digital twin interface that I show you somehow, some part, where we are gonna be able to customize the interface for each demo site, and have also the 2D representation of the product and the 3D representation of the buildings, with all their also internal process for all the flow energy process. And so on. So this is our actually strategy and our workflow applied to the Italian demo case inside the European project INCUBE. And yeah, thank you. This is everything.
Thank you, Silvia. Great work. You would prefer to give the like answer the questions now, or we combine all at the end of
Yes.
the session?
Yes.
Okay. I'm also I didn't introduce myself, so I am an energy engineer from R2M, and I do also this kind of simulation actually, the building energy simulations. So it was pretty interesting topic for me. I just have one question about if is this platform like InCube the one which makes like the combination between the sensors data and the geometry data out of the scan, like, or this any other platform like where you can for example have the 3D model of the building, and in real time you select, for example, each room, and you can see the temperature of that room specific at each time if you want.
Yeah, the idea is to have in this platform, or here you can see part of the dashboard, the initial dashboard, which is let me say, a dashboard created by Kent, to have the 3D model of the building, and to, for example, yeah, go in one room and see there the temperature and some other data concerning the room. What is important in that is let me see, the software can do a lot of things actually. Obviously, it's important to balance what is the use of this data, because maybe know exactly the temperature in that room every 5 minutes is not so useful, but maybe it's more useful to understand if during the day there was a overheating situation. So this platform is able to say the actual temperature of each instant. But for us it was more important actually to detect the critical issues, let me say, the part of the building that the part of the temperature, for example, that exceed the normal ones. But yes, the idea is to have a 3D model and be able to select some key space, some key parameter to be able to see in real data the temperature, and the other sensor recorded the energy consumption and the energy production mainly. So yes.
Okay, perfect. Thank you so much. I don't see any questions from the chat. So the last would be, what do you think would be the final scope, like at the end of the project, and where you planning to reach, like which would be your more optimistic scenario out of this project?
Well, yeah, no, sorry.
Yeah, that's it.
Well, considering that this building is a municipality building. So for us, the important things is to give back, to give the possibility to to the owner, so the municipality of Trento, to give them the possibility to be able to manage their consumption, because actually now the fact that there is this very big building which is used for offices, there is theater, there is gym inside this building, doesn't allow them to have a control of all the consumption of their energy. So it's really our efforts. It's to do efficiency. To be able to let them understand how much this building is consuming, or how much the temperature also affect the users of the building, because actually there was some problem at the south of this building. There was a very overheating periods, and so also to act to have an indoor environmental quality, to improve the indoor environmental quality. So the final goal is to let the municipality of Trento understand the criticality and to act to actually improve what need to be improved.
Okay, yeah. I assume maybe do energy efficient measurements, like future energy saving project.
Yeah, exactly. So exactly. The aim was to efficiency, the efficiency, exactly.
Okay, perfect. Thank you so much for your presentation.
Thank you.
You can now stop sharing your screen if you want. Thank you. Now we give it to the second speaker, which is Project Indicate Life Methodological Development for Whole Life Carbon Assessment of the Italian Building Stock by Irene Mazzei. You can go ahead.
Hi, thank you. Good afternoon, everybody. I'm gonna try to share my screen, and hopefully you can all see it. Yeah. Okay, good afternoon, everybody. So I'm Irene, and I work with Professor Elisabetta Palumbo at the University of Bergamo. And so today I'm going to talk to you a little bit about the Indicate Life project, and especially some updates from the Italian consortium on the methodological developments and the early assessment updates of this project in the Italian context. Before I begin, I would just like to introduce you to the Italian consortium very quickly. So we are where the consortium, let's say, puts together different types of organizations, both academic and non-academic. So we are obviously led by the Italian chapter of the Green Building Council. We have consultancy firms, public research authorities, and there are three academic institutions. So obviously the University of Bergamo, the Politecnico di Torino, and Politecnico di Milano. And on these slides, you can also see some logos from the project coordination team. So the Indicate Life project is actually co-funded by the EU and by other partners. You can see the logos on the screen. So before I jump into the actual presentation, just a little introduction on why projects such as Indicate Life really exist. I'm sure you're all very aware that the built environment has been found to be a major contributor to global CO2 emissions, contributing to up to 42% of global CO2 emissions. So it's actually, and this comes from direct and indirect emissions from the buildings processes and operations. So it's actually very key to start decarbonizing this sector to mitigate the climate emergency. And I'm sure you're also very aware that the EU is very active in this context, with policies and regulations all centered around the European Green Deal. One of the key objectives of the European Green Deal is to reach climate neutrality by 2050. And one of the key enablers of this objective is actually the Energy Performance of Building Directive, so the EPBD. So in the context of this directive, there is basically the progressive decarbonization of the built environment. And historically, the EPBD was really based on the reduction of operational emissions. So obviously, all the emissions generated by the use of the building, such as the energy used to power the building, to heat and cool and light the building. But through the latest revision of the directive, which came last year in 2024, we actually saw the introduction of requirements to assess the whole life carbon of the building. So this means not only focusing on the operational emissions, but on the emissions from the entire life cycle of a building. So coming from the extraction of raw materials, their transport, their manufacturing, through to the transport to the building sites, construction and installation processes. So we have then repair and maintenance and refurbishment cycles across the building life cycle. And then the decommissioning of the building with the waste processing and disposal at the end of life of the building. So this means that really there will be a need to disclose the emissions generated by buildings in each one of these life cycle stages. And also that the building owners will need to report this carbon footprint of their buildings. So this means that the focus is shifting a little bit from the operational emissions to the embodied emissions, where we will see at the end of the presentation there is actually a big opportunity to decarbonize and to reduce our emissions. And why do we need to do this? So I was mentioning earlier that the EU has pledged to reach climate neutrality by 2050. And this can only be achieved if we tackle both emissions, operational and embodied. So right now, we hear talking about nearly zero buildings or net zero buildings. And that, in most cases, still refers to operational emissions. But what we really need is to achieve net zero whole life, like whole life net zero buildings. So net zero emissions, both from operational and embodied points of view, with the use of offsets where and when necessary. And so what is Indicate Life's role in all this? Well, first of all, the way we achieve the EU's targets is to really create supportive policy measures that really guide and impose requirements on buildings' emissions, and Indicate really works towards that with a strong basis on stakeholder engagement. So you saw many partners are, for example, involved only on the Italian side in this project, and we collaborate with other member states as well. So there is and each consortium collaborates with other stakeholders to collect data, to collect case studies. So it's really a big network of collaboration. And this really allows us to build a strong data foundation, which encompasses the definition of whole life carbon assessment methods, strong data sets, reliable tools, and this is this is fundamental to build robust methods. And after that, we work towards the definition of performance requirements. So, for example, the definition of whole life carbon targets, whole life carbon benchmarks, and this is the only way by standardizing whole life carbon requirements that this can be put into regulatory frameworks and can be used as a compliance tool as well. And so a little bit more detail on the Indicate Life project. So as I was mentioning, it's a EU co-funded project that runs between 2024 and 2026. And its focus, again, is to improve whole life carbon data and methodologies for building across Europe, and to really support the development of national benchmarks and policies to reduce life cycle emissions in the construction sectors of each member state, but also at the EU level. Why it matters, we saw how big of a contributor the built environment is in terms of CO2 emissions. And an issue that we find is really the lack of reliable LCA data and tools. There is a lot of fragmentations of methodologies, which are actually essential for the implementation of effective decarbonization policies. And finally, it helps align the construction sector with the EU climate neutrality goal. As I was mentioning again, the partners of this project are different member states. So we have Austria, Croatia, Italy, Luxembourg, and Hungary. We have BPIE, so the Buildings Performance Institute in Europe. Then we have K11 and Smith Innovation as other partners. And Indicate actually has been around for a while, because the Indicate pilot stage began in back in 2022, and it saw Ireland, the Czech Republic, and Spain as the three, let's say, pilot member states where this project has been developed and it really started. And at the end of the 2-year project, there was, let's say, the results were very interesting, and each country was able to provide and produce a data set of whole life carbon values for different building types and different different building with different characteristics and different building types. So we'll see a little extract from the reports later. And so after the pilot phase, we are now in the second chapter, let's say, of the Indicate project, which is called Indicate Life, which started last year and will end next year, and sees other countries, as I was mentioning earlier, as an extension of the scope of the first Indicates, to actually collect a bigger sample of national data sets for the whole life carbon of buildings. And so the challenge, as I was saying, it's the lack of reliable and consistent LCA data, which is a major barrier to have reliable and consistent whole life carbon data sets for buildings. The solution would be to improve the quality and availability of building LCA data. And to have more data is the only way to create shared and robust benchmarks. And having these benchmarks is a way to support the effective definition of decarbonization policies and roadmaps. And the role of Indicates is to act as an accelerator, because it really, as I was saying, it puts together all these different research institutions, different countries, and collaboration in this type of projects is really key to reduce the fragmentation and improve harmonization of the methodologies and data. And so, sorry, there is a little mistake in the numbering. It should say 1, 2, 3. But in this slide, I wanted to just show in a little bit more practical way what the 3 main objectives of this project are on the national context. So we have, first of all, the objective to harmonize the whole life carbon assessment methodology between Italy and the other EU member states that participate in the project. So we also want to develop a robust national set of impact data by applying this whole life carbon assessment method to representative case studies, so that really reflect characteristics of the Italian territory. I will explain this a little bit more in detail. And finally, we want to establish national whole life carbon benchmarks and targets that will be used to inform decarbonization strategies and really drive policymakers and industry to set achievable and realistic targets and pathways to reach net zero. And so the steps, let's say the phases involved in the project, we start with the development of a national methodology. And when I say development, I don't mean that we reinvent the wheel. We don't create a new LCA methodology. We just take what existing tools and initiatives we have available at the national scale, and we try and define a shared methodology that also shares the same objectives and aligns with the with existing EU directives such as the EPBD. Then we have the application of this defined methodology to a set of case studies. So we have, we had a stage where we were collecting case studies from the whole country, and the objective is to analyze these case studies through the methodology that was developed. And finally, obviously, we will analyze the impact results, and the result of this will be, the national benchmarks that will be hopefully used to drive to define recommendations and drive national and European policies. And so when I mentioned the Italian methodology, so first of all, in Italy, we don't have a national methodology, a national or harmonized LCA methodology. But what we do have is a green public procurement strategy that is based on some minimum environmental criteria. And this applies to public buildings. So we took this minimum environmental criteria, and we also took a guidance book defined by the Green Building Council that is called Tools for Decarbonization, which explains, which sets standardized ways of assessing greenhouse gas emissions of each life cycle stage of buildings. And so by combining these two approaches, we defined the Italian methodology that we proposed for Indicate Life. And the content of these approaches were used to define the scope and the design features, let's say, of the methodology, such as, for example, the functional unit, the reference service life of building, the types of buildings, the construction types, and so on. Then we also define the assessment and calculation methods, including nationally relevant assumptions, data sources, calculation tools, and reporting and aggregation methods. A very important step, a key step, was the definition of national building archetypes. So a building archetype is really a virtual building that is like a representative building of a group of different buildings that share some characteristics. And it's usually defined through a bottom-up approach, so from statistical analysis of existing building stock. And it really is useful to have representative, let's say, building case studies that are relevant for the national context. And on the screen here, you can see some factors that are important to consider when defining a building archetype. So we have, obviously, it's important to analyze the building stock data, what kind of activities are relevant for a national context. For example, if it's, new buildings, retrofits, type of deconstruction, demolition activities, and so on. We have obviously the different building types, energy performance, and different elements, materials, and construction techniques that might be relevant to certain types of buildings and not others based on the performance requirement. And so we applied a similar strategy to our methodology. And in particular, there was one aspect that was very, very relevant for us to consider, which is the subdivision of the Italian territory into seismic and climatic zones. Because as you can see from the pictures, Italy is really a heterogeneous territory when talking about seismic and climatic zones. So we have climatic zones from A to F, A being the warmest, let's say, especially in the south, F being the coldest, as you can see, the blue one in the north. And then we have 4 seismic zones from 1 to 4, 1 being the highest seismic risk and 4 being the lowest. And obviously, as you can imagine, building characteristics massively change across these different areas. And they obviously affect the building materials, building techniques, and energy performance. So it's really important to consider these aspects. Another aspect that we obviously consider was the definition of different building types. So we had, for example, residential, single family, multifamily, offices, services, schools, hospitals, and so on. So we have a variety of building types to cover as much as we can of the Italian building stock. And then obviously we consider 2 different construction types, so which is new buildings and renovation. The renovation type was actually very relevant because we found that several case studies were actually renovation case studies. So we understand that this is a peculiarity of the Italian building stock. Here you can see a little overview of the distribution of our case studies. Obviously, bigger circles mean more case studies in a specific area. And so you can see that we actually have quite a good distribution of case studies in the different climatic and seismic zones. So we have case studies from zone C to zone F for the climatic zones. And actually, if we look at the statistics, we have between these zones over 95% of the Italian building stock. So there are many, over 95% of the municipalities. So there are many municipalities really located in zones A and B. So even though we don't have case studies for those 2 zones, we still cover 95% of the rest of the building stock with the case studies that we've got in the other zones. For the seismic zones, instead, we have case studies covering zones 1 to 4, so all the seismic zones. And again, in this case, we find that zone 2 and zone 3 cover about 70% of all municipalities in Italy. So we have a good distribution, again, of case studies that are representative of the territory. And then we can move on to the assessment. So the way that we constructed the assessment system, this starts obviously from a building bill of quantities, and then we take the building and we defined a tier like system to organize the building. So we have then building elements, building sub-elements, and then we can assign one or different materials to each building sub-element. And obviously then we analyze the operational energy and the operational water. And we also created an inventory of data, of impact data, that we can allocate to each material and energy flow in the system. And obviously of each building element, sub-element, and material, we consider all stages, so not only the production stage, but also transport and end-of-life impacts. So the reason why we decided to proceed this way is because having a standardized impact dataset for the entire consortium allows us to, again, standardize the results. So we have higher level of comparability and more consistent results that we can share with the rest of the project partners. And we will report these results for each let's say for each stage, for each element, per life cycle module, per life cycle stage, and as a total whole life carbon. And so doing this for each element, for each material, will really allow us to understand which are the impact hotspots of our building and of our model. So that will hopefully give us useful insights. And so at the moment, we are just starting this. We are just starting to assess our case studies, and we'll hopefully be able to produce some results soon. And the type of results that we will produce will more or less look like this. So this is an extract from the report that was published at the end of the first INDICATE, so the pilot project for INDICATE. And so these are embodied carbon intensity values for Spain, Ireland, and Czech Republic for different types of building in different life cycle stages. And as you can see, the first thing that we notice is that the production stage, so the green bars, are really the hotspots here. So most of the embodied emissions of these types of these different types of buildings really come from the production stage. And so this really gives policymakers a good indication of where the opportunity to decarbonize really lays. And another thing that we can notice is that across the different building types, the trend followed by the data is more or less the same. And what changes is actually the absolute values of the emissions. And this is reasonable to expect because we're still talking about different countries. And so obviously we have different building standards, different materials, different energy grids. And so this is really reflected in the data that we find. And so to just summarize and really take a step back and understand where we're at. When we look at the roadmap for the Energy Performance of Building Directive, we're really at the moment where it is really important that member states start defining national whole life carbon assessment methodologies, because it's important that we start defining those targets and those limit values, because by 2030, all new buildings will need to disclose life cycle global warming potential data, so whole life carbon data, and they will also need to comply with the limit values that will be set in the national roadmaps. So we're actually here right now at the moment where we are doing this work. So it is very, very important that we have these collaborations and this Europe-wide project. And for us, for the Italian context, we really think that the results of this project will support the development of our national roadmap. Right now, we are assessing over 50 case studies, but obviously, this project is only the beginning. And we really hope that we can achieve a robust development of national benchmarks, and that the benchmarks will encompass the peculiarities of the Italian building stock. And to conclude, I would just like to do a little call to action. So as I was saying, it's really important that we collaborate and work together. So if you would like to know more about INDICATE, or if you want to contribute with some case studies, don't hesitate to get in touch. And for now, thank you for your attention.
Thank you so much, Irene, for the really interesting presentation.
Thank you.
Um, okay, I have some questions about it, just for the get more deep into the topic.
Mhm.
First, as you said, this work in progress, of course. So
Mhm.
I would like to know if you already created these archetypes that you mentioning, especially about for example, the correlation between the seismic zones and the maybe the carbon emissions out of the construction or the renovation or the already embodied carbon out of the buildings. Since for me this was really interesting, since I've never thought about it. Like, of course,
Mhm.
the different climatic zones is for sure directly um, the consumption, of course, of the energy, and
Mhm.
because of that, the carbon emission produced of the operation of the buildings is directly proportional to the climate. But
Mhm.
I haven't figured out that also the seismic could be one indicator about it. So
Yeah.
I'm interested in about which, if you already get into this phase, and which are the correlations between the seismic
Yeah.
and the
Thank
carbon
you.
emissions.
Yeah, it's an interesting thing to consider. So at the moment, as I was saying, we are starting to collect all the different case studies and organize the different case studies. As you can imagine, it takes ages to do that. But we're starting to observe what kind of difference we can expect between the different seismic zones. Um, uh, uh, First of all, it really depends on the type of building, because, for example, we have some case studies where the building structure is, as I can say, maybe overbuilt. So even if it's maybe a seismic zone that is not that high risk, the structure is overbuilt, and so it's there is more structure than it would be
Yeah, it will
needed.
damage the correlation.
Yeah, so we will really need to wait until we assess all the buildings to understand where we can see and the magnitude of the difference of the design requirements related to the different seismic zones. But there was also some work done on this by the first Indicate, so the pilot project, because in Spain they also have this type of the territory also have these different seismic zones, and they saw that the structure impacts change quite a lot based on the different seismic design requirements. So it's been observed before. It's not been really studied in detail, so we're really excited to understand more about it.
Okay. Yeah, we're looking forward to
Mhm.
also hear about it. Thank you so much.
Thank you.
That's it for the second presentation.
Can I jump in
Ah,
and
of
yeah,
course.
just ask a
Sorry.
question? Yeah. Hi, Irene. Thank you also for this presentation. It was very interesting for me. I have also a civil engineer background and a master in earthquake resistant design of structures. So it was really nice to see the correlation. Are you planning to create something like a registry of whole life carbon data sets, or I don't know, like the EPC registry, something like that?
Yeah, so thank you for the question. One of the goals and objective of Indicate is actually to have a open access platform that people can use, to get data, to access, target values, benchmark values, and so on. And so that is accessibility, and improving accessibility is one of the objectives of Indicate. And so yes is the short answer.
I understand it should take a lot of time. I mean, to develop the methodology, the roadmap, and then create the registry.
Yeah.
Is there any available report on your work?
There is the report available for the pilot, which is here on the slide, because for now the report is published at the end of the 2 years of the project. So at the moment we're still basically right in the middle of the second indicate, but you can access the first report, which is very interesting. And yeah.
Thank you. And it would be nice also to see how this can be coupled with some digital tools to facilitate the process and also decision making. So,
absolutely.
Thank you.
Thank you.
Thank you for the question.
I can stop sharing.
Yes.
Oops. Yeah.
Okay. Thank you again, Irene, for the pretty remarkable, interesting presentation. Now we go ahead to the third and last one of the presentation of our paper session, which is how can we build an accessible and inclusive built environment, which would be divided in 2 parts. I don't know if you already decided if the parts will be combined in one presentation, or we just...
We have actually 2 different. I will start and Mattia will follow, but we can probably see if there are any questions after both parts.
Okay, perfect. Yeah, good. So we can start with part 1. So I'll give the stage to Panagiota. Thank you.
Okay, thank you. Today I'm going to present the Access project. Stands for Enhancing Accessibility and Sustainability in Smart Cities and Smart Buildings, the Universal Accessibility Suite. So the aim is to discuss how we can build an accessible and inclusive building environment. And this is what the Access process aims to facilitate, to give some background context on how this project was created. We identified some needs and problems. Cultivating a culture that values diversity and promoting solutions for accessible built environments is imperative to ensure inclusivity and equal access for all individuals. And creating accessible smart cities involves comprehensive urban planning, integrated infrastructure, transportation, and public spaces under a user-centered design approach. All this can be facilitated by digital tools that address the relationship between comfort, energy consumption, and user needs, while also meeting the enhanced accessibility requirements of people with disabilities. And this will enable designers to optimize energy efficiency without compromising user comfort and accessibility. The operation of smart buildings is also important, so adapting buildings to accommodate disabled individuals is essential. And we, as an overarching idea, is that a comprehensive and harmonized certification framework would aim to provide a standardization and integrated approach for evaluating and promoting accessibility. So what Access envisions to do, and initiated on June 2024, is to create barrier-free environments, facilitate smooth mobility, and revolutionize the accessibility and inclusivity of smart buildings and smart cities, enabling equal access to essential services and facilities. The project includes customization and personalization, sustainable and energy-efficient infrastructure design, operation management and optimization, universal design principles in products, simulation-based testing and compliance with accessibility guidelines, and a common classification system for accessibility features. We are 22 partners from 9 countries. We formulate quite a multidisciplinary team of academia, industry, and research community working on smart buildings and smart city design and operation, along with accessibility aspects. The novel elements of the project are based on a methodological framework formulating the basis of a user-centered design approach This will enhance the capability of access partners to effectively address and leverage social inclusion and accessibility. This approach has been already delivered as part of the project, as it is being considered during the development of our tools, and will be presented in the next part. Another core element of the project is the comprehensive accessibility assessment scheme for the built environment. It aims to address physical accessibility, usability, safety, comfort, and social inclusion in the standards, and define clear and measurable criteria and performance indicators for assessing accessibility. Access is supported by digital innovations, both for accessible and inclusive design and adaptive and sustainable operation of the built environment. All solutions are integrated all together under an inclusive toolbox, the Universal Accessibility Suite. I will get into a few details about our digital tools to see the connection also with the UCD approach that we have designed. We have an energy efficient sustainable design tool that is a comprehensive platform designed to enhance building energy performance by facilitating the evaluation and optimization of renovation scenarios. The energy comfortness tool aims to enhance efficiency while ensuring comfort and explore the relationship between comfort and energy consumption, and encouraging the adoption of sustainable practices. So it kind of introduces the energy comfortness concept. ErgoFlow tool focuses on offering designers and manufacturers the means to ensure that their products meet ergonomic criteria, providing comfort, accessibility, and safety for all users, including those with disabilities and elderly adults. The virtual user models and film-based virtual humans represent aging individuals and people with disabilities. These models integrate anthropometric data and human factors, which will be used to generate virtual humans for simulating and evaluating accessibility in 3D environments. So this is combined with the 3D scenario simulator that will orchestrate the synthesis of the 3 environments and will integrate the virtual humans in order to generate simulation scenarios in different contexts. On the building operation level, we have the building operation and management system. The tool is intended to improve building energy efficiency by dynamically balancing comfort and user behavior, and also cost savings. It incorporates forecasting models to provide predictions about energy generation and consumption. This is based on user behavior, environmental factors, and historical data. So the idea is by utilizing these projections to provide suggestions for maximizing energy efficiency, minimizing expenses, and ensuring occupant comfort at the same time. The EV charging optimizer is the integrated e-mobility service of the Access project. The primary objective here is to develop an inclusive and accessible EV charging infrastructure that caters to the needs of all users, particularly people with disabilities and the elderly. This involves analyzing user behaviors, identifying accessibility requirements, and integrating this consideration into charging schedule optimizations. And the last tool of the Access suite is the Universal Accessibility Assessment tool that is going to realize the under development accessibility assessment scheme of the project in order to assess the design and operation of buildings and infrastructure. The scheme will encompass not only physical accessibility, but also usability, safety, comfort, and the crucial aspect of social inclusion. So this will be reflected also in the assessment realized by the tool. Depending on the pilot sites, Access Suite will be demonstrated in 6 pilot buildings. We have grouped pilot cases under 3 groups. The case of cultural heritage buildings includes the Christo and St. Cloud Center in Gabrovo, Bulgaria. The center's renovation is currently at the design phase, so this offers a unique opportunity to incorporate specific accessibility requirements for vulnerable groups. Under the same case, the Brancacci Chapel in Florence, Italy, is a cultural heritage building, a UNESCO monument. So the idea is here to transform the chapel into a pilot model of an open museum that is accessible to all. The second group includes people care facilities. We have Drum de Tash Foundation in Naldik, Netherlands. It's a so-called Parents Initiative. The aim is to assess building and surrounding area accessibility, identify improvement opportunities, and enhance inclusivity for residents, and reducing dependency on support from assistants and parents. And also Casa Girasole in Massagno, Switzerland. The overall aim is to improve energy efficiency and indoor air quality and comfort. And specifically for this pilot, we are developing a charging area for electric vehicles to be designed with accessibility as a core principle. And this will be realized in the adjacent park to Casa Girasole to serve both visitors and workers. The last case includes public services buildings. We have the Palazzo Tizittà in Bari. The overall aim is to enhance accessibility of buildings and public services for vulnerable groups. And this also includes the workers in the Palazzo. And Mercado de Verónicas in Murcia, Spain is aiming to transform the market into an inclusive space for individuals with disabilities and vulnerable groups, and ensure step-free access across the market at all areas of the market. So that means independent mobility. This concludes my presentation. And I think we will see next part, the UCD approach of the project.
Thank you, Panagiota. Yeah, I will present now one of the methodological pillar of the Access project, which is the user-centered design approach. First of all, a definition of the user-centered design approach, which is an iterative design process in which designers focus on the users and especially on their needs in each phase of the design process of a solution. And this approach, I think, sorry, I hear some background noise. I don't know. Okay, thank you. This design approach is particularly relevant within the context of the Access project, which focuses on building more accessible and inclusive built environment. So this is related, of course, to people with vulnerabilities or disabilities. And the user-centered design approach involve users throughout the whole design process of a solution, and it does so with a series of tools, research tools, and collaborative design methods. So in this way, we ensure that the developed products, which in this case are digital solution for the Access project, meet the needs of the people, of the users of the spaces and of the built environment. We will go through in a moment in the detailed phases of the UCD process, but first of all, we can say that we have four macro areas of activity in the UCD process. One is, of course, understanding the context of the environment in general and also the constraints. Then understanding and assess what are the users' needs related to the built environment and what are the barriers that make the built environment not as accessible as we would like. Then, based on this assessment, we could design the solutions, in this case, digital solution that would help in reaching the objective or more inclusive and accessible built environment. Then these solutions are to be evaluated at the end. at the end when they are designed and delivered. So this is, let's say, an anticipation of the six phases of the UCD approach. Again, three main principles about the approach are, of course, the user centrality. So understanding the user's needs, desires, and challenges. The iterative approach, meaning that the UCD approach is a cycle. It's an iterative and learning with a lot of feedback loops and input coming from the different stage of the process. And of course, another very relevant principle of the UCD approach is that it needs a multidisciplinary collaboration. So in the Access project, as also Panagiota was anticipating before, there are different type of competencies that are involved that are not only technical, engineering, energy, and so on, but there are social sciences and humanities competencies that are involved in the project. There are advocacy groups and disability groups. So it's very relevant that there is a multidisciplinary collaboration to have a proper user-centered design approach in a project, which starts with the design challenge, which is the first phase of the approach. During this phase, we design the generative question that will guide the whole process, from the understanding the user's needs, which is let's say the discover phase, as it is called. Then after the needs are collected, the information is collected, we can then analyze and make a synthesis of the results and the needs and connect them to the innovative solution that the project expect to deliver at the end. So at the current stage of the project right now is this, where this innovative accessible solution presented by Panagiota before are being developed based also on the information that were collected thanks to the UCD approach. Then of course the solutions are prototyped and tested, and then it is time of collecting feedback and so on, and then deliver the final solution. And then again, the cycle might start again in other projects and in the pilot sites that will implement this solution. So as anticipated, we start from an initial design challenge, a design question, which is a generative question that guides the whole process. So we made three different design questions based on the three clusters of the cultural heritage buildings, people care facilities, and public service buildings. There are different focuses per each cluster, which were of course defined together with the consortium, with the demo sites leaders, based of course on the general objective of the project, based on the different type of buildings which have different characteristics also in terms of accessibility and in terms of openness, let's say, to the public. It was possible to make three different questions. For example, for the museum and cultural spaces, the focus was on ensuring easy navigation and comfort for visitors and workers, while in care facilities, which already have a strong attention on the inclusiveness and accessibility of the spaces, the focus was on enlarging the view not only to patients and people who live in these care facilities, but also to families, and to take into consideration the point of view of workers, which also might have some needs in terms of accessibility and vulnerability needs. And then the case of public service buildings, of course, is very relevant in terms of general public accessibility. So the public service building has to be per se accessible to all the citizens. So this has to be taken account when developing a technical solution. So how the user needs were actually collected. It was used a mixed methods approach. So we collected information from the stakeholders using surveys, interviews, workshop, and desk research. So it was both desk research, interactive work together with the stakeholder and the users of each demo sites, and more than 280 participants were involved to understand their needs based on each pilot site. So just to give a few examples of the category of stakeholder that were involved in the process. For example, from the part of end users, visitors of the buildings were involved, residents, for example, in the people care facilities. Of course, also employees and staff, conservators and operators in the public service buildings, in the museum were involved. They were able to express direct experience and needs in the everyday use of the built environment. Then civil society and advocacy organizations were also involved, which gave us insights on the systemic perspective and on general barriers and constraints also. And then, of course, institutional and administrative actors, which most of them were also partner of the consortium. They shared their point of view, especially in terms of policy and regulatory constraints. So the data collection on the user's needs was aligned together with the regulation about the accessibility of the built environment. And so the question that we asked to the users, the data that we collected was based on these 8 areas of accessibility, which are part of the regulation. So after that, after the data was collected, in this way, we were able to analyze the user needs and barriers that were present, that were reported by the users and all the stakeholders. Of course, our report is just very few needs and barriers. It's very short summary of all the main findings, but it's just relevant to say that these findings were collected by the users to inform the digital solution and to connect what are the needs of everyday users together with what could be the digital solution. In this way, by analyzing this feedback, the aim was also to bridge the gap also between the technical developing of the solutions and the everyday user needs. Anyway, about the cultural heritage buildings, main findings were related to the restricted spaces, the conservation limits, and a lot of constraints in terms of cultural heritage conservation. So the rules about this are very strict and might condition the implementation of digital solution. In people care facilities, we focus on more mixed user groups, more broad than just focus only on the residents, but also, for example, on the operators and on the families that visits the residents in the people care facilities. So, and of course, the focus was on comfort and safety of these people which for sure have already some vulnerabilities. And then on public service buildings, there was a strong focus also to mobility and infrastructure and how the public buildings are connected to the whole city and how it's easy and accessible to circulate, to reach this building. Of course, these findings, these needs and barriers that were collected cannot maybe be fully addressed within the scope of the project, but they inform, at least in some way, the digital innovation that are being developed. So what we collected was translated in a roadmap, which is a set of recommendations for developing the tools. And so here are some main roadmap priorities for each pilot group, again, that are supposed to inform our technical partners of the consortium for developing digital innovations that might respond or at least ensure that the solution itself itself are accessible, and the solutions make the buildings and the built environment more accessible for the needs of the users. As anticipated, right now we are in the develop stage of the solutions, and then these are more or less the next steps of the project. We will go through a pilot implementation and testing of the solution. And then this prototype and tested solutions will be again under a new round of the evaluation. They will be assessed through KPIs and qualitative feedback from users, from partners, and so on. So to validate them at the end. Based on the user-centered performance. And then this will help us reach a final, let's say, design of the solution. Again, these results are, of course, a short summary of what is collected in a more broad report, which is deliverable 2.1 of the project, which is available on the website of the Access project. So where you will see detailed user needs and roadmap per each pilot site. And also here we focused on the built environment, while on the deliverable 2.1 you will also find some information about the needs and the barriers that were collected about active mobility solutions, which is another part of this activity of data collection and stakeholder engagement. So some key takeaways that we think are relevant based on the experience of applying the user-centered design approach in an Horizon Europe project, in the Access project, which aims to develop digital solution, is that the UCD approach aims to help to bridge the gap between the technical design, the policy point of view, and the real user experience. And this is possible, as anticipated, with a multidisciplinary collaboration among different type of partners. Then, of course, we must consider the intersectional, intersectional point of view. So accessibility, usability, comfort, and sustainability must be pursued together. So they're not separate objective, but they have to be taken into consideration altogether. And then again, when we talk about accessibility, we should consider physical, cognitive, sensory, digital, and community aspect, and also from an intersectional approach, because we cannot we have to consider also the interconnection between different type of vulnerabilities. Then, of course, the engagement of the stakeholders and of the users helps to co-create together with them, and also helps in establishing a long-term accessibility monitoring. As an example, in the case of the Brancacci Chapel, where a survey was developed for the users, for the visitors of the Brancacci Chapel, our let's say questions in the survey were now implemented permanently. So, and now the municipality of Florence is monitoring continuously the perceived accessibility of the space through their direct, let's say, visitor survey. Of course, this brings us to the final point. At the moment, the UCD approach has provided findings to inform the solution, but also some information that were collected are already informing the decision in pilot sites, also in terms of physical solution that each partners might implement at their own sites. Of course, we have to be very aware of the type of participation that we expect from stakeholders, because what we want to avoid is the consultation fatigue. So when we engage with stakeholders, we must ensure that we do not create false expectations, and the user involvement, for example, is as much as possible interactive and helps really making participation meaningful, especially when we talk about people with vulnerabilities or advocacy group of that kind. So that's it from our side. Thank you for your attention. You will see also the website of the project as anticipated, where you'll find the complete report on the results of the process. Thank you.
Thank you so much, Mattia and Panagiota, out of this interesting topic. One question I would do is, in the pilots you mentioned, and of course there are different typology for building, and you made different type of analysis out of these three different typologies, no? Like different questions, different because of course it's an user-based analysis and not a general analysis. But at the beginning, one of the scopes out of this project is like developing a comprehensive and harmonious certification framework to provide a standardized and integrated approach for evaluating accessibility in buildings. No? So I would ask you, how would be the process if out of this making this analysis particular to each type of building, but trying to create the global general approach which could classify out of all different type of buildings, and no matter which type of use and no matter which type of category or users they have.
Mattia, can I start? You maybe?
Yeah, go ahead. Yeah.
Well, this is not only relevant to the UCD approach, but what your question actually refers to the accessibility assessment scheme, which is a very important component of the Access Suite and the Access project. The idea behind the methodology that is currently under development, and we had the last 2 days our last GA, and for the first time the first version of the methodology was discussed. So I can tell you more details that the way we are formulated this assessment scheme, of course, we're not reinventing the wheel here. This is based on the N17 2010 standard, and also we're considering NEB guide for assessment. The methodology is broken down under different accessibility dimensions. So we are considering different different disability types. So it can be either physical or sensory disability type, or cognitive categories, and this is also considering assessment dimensions in the sense of physical accessibility, wayfinding and navigation. We are taking inspiration from the available standard on the different categories that can be also assessed, and this can be measured through some evaluation criteria. This process is guided by another partner in the project, the Frederick University, and supported by the Romanian standardization body ASTRO. It's not closely related to the presentations today, in the sense that we have final results on how the UCD approach translates into the scheme, but this can be an interesting idea to see, now that we have first results of the assessment scheme, how the different needs of those people are incorporated into the different disability types and accessibility disability dimensions that we are evaluating.
Yeah, not much more to add, if I may. One thing about the user-centered design approach at the moment, in particular the stage of the discover, let's say, the collecting of the users' feedback and users' needs, is that at the time we can consider that at this time the data collection is a sort of more broad data collection about the user needs, which need to converge in some common ground, which could be represented, as Panagiota said, about a different area of accessibility of the European regulation. So the users' needs and barriers collected were broader than the scope of the project itself, and were helpful also to the pilot sites leaders to implement some different solution from the digital one that are being developed from the project. So it was a sort of divergent and more broad activity that now needs to convey in a common ground that can be found in within the project and the accessibility scheme and all the other let's say common tasks and activities between the different three type of groups of pilots. Yeah. Thank you for that.
Thank you for the answer so much. I don't know if any people in the audience can have another question, or we just make that for today. Probably not. Thank you so much again for everyone. I don't know if the other presenter people are still here. Irene, I see you. I don't know about the others. I was glad to have you here in these sustainable places. I really like that the word sustainability is not only used in the previous terms, but now we have a broader approach, as we can see, like also having the accessibility, also having the life carbon assessment, which is a huge part of it. So I'm happy to have monitoring this work site, this paperwork session, and that's it. Thank you for all the presenters and for all the people who have joined us virtually.
Thank you.
And
Thank you from our side also. It was very interesting.
we will create the registering in the recording of the meetings, and maybe it will be available soon for you also to rewatch it and to share it for your scopes. Okay, thank you so much. Maybe we see you in the future.
Thank you. Bye.
Bye bye.
Cheers. Bye.